Okay, so you're looking at this one. Assume for n equals k, that would be that, plus 2 on 3 factorial plus n on n plus 1 factorial. Now you're trying to make it, actually I have to say k, not n. You're trying to make it equal 1 minus k plus 1 factorial. I'm just going to neaten that up a little bit. So it's going to be 1 minus k plus 1 factorial. Okay, required to prove that 1 on 2 factorial plus 2 on 3 factorial plus k on k plus 1 factorial plus one more term, because we're going to prove for n equals k plus 1, so we have to go one step further. So it's k plus 1 on k plus 1 plus 1 factorial. We want to prove that equals 1 minus k plus 1 plus 1, which is k plus 2 factorial. And I'll just make that one the same. That's going to be k plus 2 factorial. Okay, so the left-hand side is the sum to k plus tk plus 1. The sum to k is represented by that. That's the sum to k. And the tk plus 1 is that one. So that in place of the sum to k, we're going to put 1 minus 1 over k plus 1 factorial plus k plus 1 on k plus 2 factorial. So we want to make that equal our prize, which is on this side. Okay, so if you look at that, we need to get a common denominator. Now, which one's the biggest, k plus 1 factorial or k plus 2 factorial? And k plus 2 is bigger than k plus 1. So if you take the one that's the bigger, that would be k plus 2. And then if you pull out, the next one down would be 1 less than k plus 2 is k plus 1. So that equals k plus 1 factorial. You've got to realise that if you pull the first one out, the next one is 1 less with a factorial, because it's n minus 1, n minus 2, n minus 3, n minus 4. You could also pull out two of them, n minus 1, n minus 2 factorial. So you could do that also. So when I'm trying to find a common denominator here, that's k plus 1. That would be k plus 2 on k plus 1 factorial. So if you look and get the common denominator, the thing that's missing for this one here is the k plus 2. So if you multiply that by k plus 2, you also have to multiply the top by k plus 2. You also have to be careful of this negative when you're simplifying, and just make sure you keep your eye on the prize, which is over there on the right hand side. So I'm just going to rub this out here so I get a little bit more room just to finish this off. I'm keeping my prize there. So I've got 1 minus 1 times k plus 2 over k plus 1 factorial, k plus 2, plus k plus 1 over k plus 2 factorial, which is 1 minus k plus 2 over k plus 2 factorial plus k plus 1 over k plus 2 factorial. So when you're simplifying this, because of that negative, the negative is a bit of a problem. You're actually better off probably just putting the positive one first, because this will make it a lot easier for me to explain, minus k plus 2, you need brackets because there is 2 terms, and then if you look at that, that would be 1 plus k plus 1 minus k plus 2 over k plus 2 factorial. So it's 1 plus k plus 1 minus k minus 2 over k plus 2 factorial, which is 1 minus, the k's go out. See, it's 1 minus 2 is minus 1 over k plus 2 factorial. And that was my prize. So it equals the right-hand side, proven.